College Board 10, no calculator number 4. So in this problem, we see a linear relationship in the form of a graph, but to understand what that relationship is, we need to read the word problem. So the word problem says the line in the xy plane above represents the relationship between height, h of x in feet, and the base diameter x in feet for cylindrical Doric columns in ancient Greek architecture. All right, so long story short, the x-axis keeps track of the diameter of a column, and the y-axis is keeping track of the height of that same column. And what we see from this linear relationship is that if we have a column with a smaller base diameter, it's associated with a column that has a shorter height. In contrast, because of this positive slope, if you have a column with a large base diameter, that's associated with a column with a large height. Long story short, small base diameter, small height. Large base diameter, large height. Basically, if it's a wider column, it's taller, and if it's a skinnier column, it's usually shorter. Then the question asks us, how much greater is the height of a Doric column that has a base diameter of 5 feet compared to the height of a Doric column that has a base diameter of 2 feet? So what we do is we take that 5 feet and we put that into the x-axis. Then we figure out what y value we have associated with that. So for a 5-foot base diameter, we've got a height of 35 feet. And then for a 2-foot base diameter, that's associated to a height of 14 feet. We want to figure out how much taller the tall column is compared to the short column. So we do 35 minus 14, and we get an answer of 21.